Okay, let's try out another example problem. So first off, what I'd like you to do is take a moment, try and tell a story about this initial value problem. You see it's second order. All of our coefficients are positive, so it can represent a mass spring system. Questions to think about are, is there damping? If there is damping, is it overdamped, underdamped, critically damped? How are we starting out? Take a moment, pause, and then we'll come back together. Okay, so when we look at this, we see that there is damping. And if we look at the auxiliary equation, it's easy for us to factor it. And so we see that we have this repeated root of -1. This is critically damped. And so what that means is that it's going to be returning to equilibrium basically as quickly. It's going to be returning to equilibrium quickly. We also see from our initial conditions that our system is starting out at rest. There's no initial displacement. There's no initial velocity. Okay. So we are just going to be chilling at equilibrium until time 1, an impulse is applied, a force is applied to our system. So what I'd like you to think about is sort of like long term, what is going to happen? There's an impulse at time 1. To make a prediction. Okay, and now what I'd encourage you to do, this one isn't too bad. So what I'd encourage you to do with your sheet and by your side, try and solve this. Pause the video and I'll go over the solution as well. But see if you can do it on your own. Okay. So we're going to take the Laplace transform of both sides. So we get s squared times capital Y minus s times y at 0 minus y prime at 0. That's our second derivative, plus 2 times s times capital Y minus y at 0. Plus capital Y, the Laplace transform of little y is capital Y. And then this is going to be equal to e to the negative s. All of our initial conditions are just 0. So this gives us s squared capital Y plus 2s capital Y plus y is e to the negative s. So s squared plus 2s plus 1 times y is e to the negative s. And so y is e to the negative s times this 1 over s squared plus 2s plus 1, which I'm just going to factor out nicely. Okay. All right. So on our sheets, let's go over to our sheet. Oh, there's no sheet here. One moment. Okay, so on our sheet here, we're looking for a shift. We had 1 over s plus 1 squared. So we were looking for a shift where we have higher powers. Okay, we don't see any other terms down here. So this is n equals 1 and a equals -1 of number 11. Okay, so our inverse Laplace transform of this term is going to be t to the 1 e to the negative t. That's great. So t e to the negative t. Okay, so the inverse Laplace transform of e to the negative s times 1 over s plus 1 squared is going to be u1 of t times, we said that individual inverse Laplace transform was t e to the negative t. And just every time we see a t, we're going to write t minus 1, the shift to the right by 1. Writing an R for right. Okay, so e to the negative t minus 1. Okay, and so this tells us that y at t is u1 of t times t minus 1 e to the negative t minus 1. Okay. And if we're trying to picture this function, it's equal to 0 until time 1. And then at time 1, we start with this function that is a linear function multiplied by a decaying exponential. So we're going to be growing for a little bit, and then the decaying exponential is going to pull us back down. And so this is actually the graph that this produces. So we had u1 of t times t minus 1 e to the negative t minus 1. So we started off, we were just chilling at the equilibrium. At time 1, we had our impulse, our short force applied. So it causes us to be displaced, but then we're going to be approaching the equilibrium, just going back where we started from. Great. Okay. And that is all, folks. Good job today.